We are in the section of limits, and we're looking at solving limits, a numerical approach. We have the limit as x approaches 9 of 81x squared minus 1 over 9x minus 1. Let's go to the whiteboard and write this out. Alright, we have 81 x squared minus 1 over 9x minus 1 as the limit as x approaches 9. So this is our function here, f of x. And what we're wanting to do is we're wanting to find what is our y value going to be, all right, as we get closer and closer to 9 from the left and from the right. So we could say, okay, 9, we're going to come in from the right hand side, 9 plus, let's say for example, 0.1. And then we just take this number, which would be 9.1, plugging it into this and seeing what we get out. And then we're going to get closer, 9 plus, let's say, 0.01. In other words, we're going to get closer and closer to 9, right? So this just becomes 9.01, and we plug 9.01 in and get out our y value. All right. Let me, I don't know, do a quick sketch here of this graph. And to better see what this graph is actually going to be, we'll use a different color this time. What you'll want to do here is factor this thing, and we can cancel out a 9x minus 1. And when we do that, we end up in the top with a 9x plus 1, and that's actually what we're going to be graphing, is the 9x plus 1. So this right here can actually be rewritten as 9x, the whole thing squared, minus 1. This is the top up here, and then you could factor this as 9x minus 1 and 9x plus 1. This whole idea of factoring is going to be very important in the next section on evaluating limits analytically. And then of course we can cancel those guys out, and this is what we're left with at the top. And so we end up with a graph. Now this is definitely not to scale, but it looks something like this here. Alright, at 1/9, if we plugged 1/9 into the bottom here, we'd end up getting 0. So this is actually where the interesting part of the graph is actually located. Okay, but it says we're approaching 9, so we'll just say that that's right here. Which there isn't a missing point at 9. We could plug 9 directly into this thing, do direct substitution, and actually get what our y value is, but that's not what the definition of the limit is. We're going to come in from the left and from the right, getting closer and closer, and seeing what our y value is actually approaching. Let's go back to the web page, and let's come over here, and I'll hit we'll hit help, okay, and see what it actually says. So we're coming in from the left hand side, right, at 0.1, 0.01, 0.001. As you can see, we're getting closer and closer there to 9, and we can kind of get an idea of maybe what this thing is actually approaching, right? And then of course we're going to come in from the right, so 0.1, 0.01, 0.001, and as you can see here, it looks like it's approaching 82, and of course we've got this written running off the page here. I can bring it over here and show you here. So we conclude that the limit of f as x approaches 9 is actually 82, and you can plug in 9 into that and just do the direct substitution and evaluate it. We'll come up here, click answer, and that's what we get is 82. Alright, so this is the numerical way of approaching this, and it will become pretty important later.